In this video, we are going to derive the Bernoulli's equation using two methods. The first method will be the conservation of energy. The second will be a simple calculation. Now, the Bernoulli's equation is very powerful because it can approximate the relation between the pressure, velocity, and elevation. But it does have its limitations. It is only valid in regions of steady and incompressible flow. So, if you're working within the boundary layers of a pipe or an airfoil, you cannot use this equation. But outside of it, you're good to go. So, for the conservation of energy, conservation of energy. So let's create a little pipe diagram. So we have area 1, area 2. So we have a mass right here with a velocity of v1, and then at some time later we have the same mass going at velocity 2. Now we will assume delta x1 from the inlet to the mass, and we will assume delta x2 from the mass at a later time to the exit outlet. Now, to have velocity and to move uphill, or through the pipe, we need a force, so we'll call that force 1. Then we of course have a opposite force, so force 2. And then we have a designated height, which we will call z1. And then we have the new height called z2. So first off, we can use and calculate to find the equation for work. So to find work, we know work is equal to the force of 1 over the change of distance of 1. Now, with force 2, it is opposite of force 1. So that is minus F2 delta x2. With force, we can convert that to pressure of 1 times the delta x1 minus 2 delta x2. With these two, area times distance, 1 of 2 as 1 volume 1 minus pressure 2. Since we know that the volume stays the same from the entrance to the exit, we have volume 1, volume 2. 1 minus P2 times volume. Then work equal to the change in kinetic energy plus change energy. And we can rewrite this equation as minus 2 times volume equals 1/2 mass times velocity squared of 1. Oh, correction, 2 minus 1/2 mass squared of 1 plus mass times gravity times height of 2 minus mass times gravity of height 1. And then we have simplified this even further. We have 1 volume plus 1 over 2 mass volume, correction, velocity squared of 1 plus mass height 1. That gives pressure 2 times the volume plus 1/2 mass velocity squared of 2 plus mass times gravity height 2. Then we know that this is mass over volume. So we can literally divide this by volume. So that will cancel out, that will cancel out. So that gives 1 plus 1/2 1 plus the gravity of 1 P2 density plus density of gravity 2. And there we have the Bernoulli's equation using conservation of energy. Now, to do this catalyst version way, we want to create again, in the z direction. Then we have this streamline. Make that a different color. So that'd be streamline. Then we will create a box. Call that delta S with a pressure times the change of area. Then we of course have a change, correction, an opposite pressure going against it. So that we plus delta P, so the pressure difference times the change of area. Then we have right, there we go. Then for normal that, we'll draw that. That will give us an angle. So let's create. So we have 4S. off to the side, I am going to create a triangle using trig for the weight. So we have over ds. So we sum up all the forces again. So we have pressure dA minus pressure plus P dA minus the weight times the angle, so that'd be sine of mass velocity dv d. Setting in sine dz over ds into sine theta and converting the weight and volume, what we have is minus dA minus density times gravity times delta A, delta S, delta Z over delta S. Density delta A V ds. So dA on both ends of leaving a D gravity minus gravity dz dv. Take the intervals are given say b minus a, so 2 minus 1 be 1 minus 2. Then we have minus again, so let's just do this. C2 minus Z1 velocity or density times velocity of V1 minus V2. Which gives us V1 over density plus half V plus gravity 1 velocity squared plus gravity times there. We have the second method of deriving the Bernoulli's equation. If you like this video, give it a thumbs up. It will help me tremendously. Leave a comment with any other recommendations you would like to see. Till next time, stay safe. Have a good one.